Hi, I'm Sean Wohltman. I'm a geospatial scientist on the enterprise team at Google.
Hi, and my name is Josh Livni. I'm on the developer relations team for Maps. So welcome, thank you for coming. This is Design Patterns for Maps Architecture. If you guys are interested in sort of UX patterns, how to make your map look amazing and beautiful for the end user, you're in the wrong session. That would be the next session coming up right after this, Design Principles for Maps. So here we're going to be focusing on kind of what happens behind the scenes as you build your application, some sort of common patterns we see developers come across on all different kinds of applications and best practices there.
So last year, when Hurricane Sandy made landfall on the eastern coast of the United States, there was a pretty interesting application that was built. It was called MapMill. It was built by Skylar Earle, some crisis mappers, John Crowley, Kate Chapman, and the site was fairly simple in its design. It showed images, and these images were collected, over 35,000 of them, by the Civil Air Patrol in various states. These were guys hanging outside of Black Hawks or outside of fixed-wing airplanes, taking pictures of what they saw on the ground. And they do that because these were the first eyes on the destruction there. So they have all these thousands of images, and what they asked was the public to come in, whether you were a seasoned photo remote scientist or if you were a novice that was just interested in trying to help out. And it was very simple. Look at the photo and rate it. Is it light damage, is it moderate damage, or would you say that this is heavy damage? And here, this picture of Seaside, New Jersey, obviously would be heavy damage. And the cool thing about it was they took the aggregate of all of those votes and created a grid. And as soon as we saw this, we saw immense potential. This was information that was going to be really helpful for first responders and for decision makers where to go and deploy assets. So we took this grid and we deployed it to the Google Crisis Map. And in so doing, we almost started to impact their server because Skylar was putting out a GeoJSON feed of this entire grid, and we basically were going and scraping it to put it into our servers on an update cycle. And we handled all the caching once it got to our servers, but that direct request every single time I was going to do an update was starting to impact the main purpose of that site. So because Skylar knows what he's doing, and he's been doing GIS for a long time and web development for a long time, he said, this is a simple solution. Let me dump this out as a cache periodically, and then you can hit that cache and not take down our site. And it's a good thing he did, because the site, not just through crisis maps, but through lots of other press releases, became very popular. So a lot of people got involved in this activity. In fact, we set traffic records on the crisis map for the amount of traffic coming in with people in the Northeast wondering what was going on, how were their homes gone? And so it's a good thing that that simple little change of rather than having a dynamic request for millions of people to having a simple cache that we then cached for them made all the difference.
Yeah, so why would you care about this? You might be thinking your application is not going to necessarily be front page of Reddit. Hopefully it is, or on our crisis map featured there. There's all kinds of applications, though, that the same set of principles applies.
That's right. I mean, what if you were building a really important local crime map and you wanted to get that information out there because it's important to people in your community?
Yeah, or a totally different real estate site. We talked about some of these last year where you've got lots of dynamic data updating to tons of people visiting on lots of different platforms.
Or what if you have an incredibly popular game like Ingress, and you've got millions of spatial points of interest that you're trying to keep track of and how people interact with them?
Yep, or perhaps you're a local municipality trying to put out some spatial data. It's relatively static to a relatively small number of people, but you need to make sure it's interactive in the appropriate way.
Or you're relying on a very dynamic feed, like the earthquake feed, and you have different visualizations that people can come in and customize to try to make a map that makes the most sense to them.
Or a super immersive application where you're really taking advantage of some of the data and imagery and terrain meshes that we have to really get people in and add a little bit of your own magic on top.
So there's various tools that you might do for this, and there's various options here at Google that you can use to make these applications work. You can use the Google Maps API and just push data into the client.
Yep, so a little bit of JavaScript there, or perhaps some KML. Maybe you're writing your own KML. Maybe you're using it as a transport across different types of interoperable geoservers.
Or maybe you have a little application that you're hosting on Drive that spits out GeoJSON, or you're pulling GeoJSON feeds like we were from an external site.
Yep. So we have a ton of different ways and services that help you, build mapping applications. And we see developers oftentimes pick and choose a few different tools and run into similar problems. And what we want to do is kind of show you through a few different stories we'll get to in a minute, some common patterns we've seen that might help you think about in advance what might affect your application as it grows. So before we get into that, though, I wanted to highlight something that Brian mentioned on stage earlier today, which is our Maps Engine platform. So this is pretty cool. I'm not sure if all of you have had the chance to play with it. What we have here is the Maps engine layer in Maps API, just loading some different layers. I loaded parcels from San Francisco and some trees from San Francisco. And you can go ahead and scroll around and click on them. And the thing I want to mention just up front, we'll talk about some more of this stuff later, is that all of you are welcome now to go ahead and get an account on Maps Engine. You can head over to the sandbox, the Google Maps sandbox, right after this talk. Give us your email, and you'll, within a few minutes, be signed up to a test account where you can play around with this. So throughout the session, we'll be referring to some of the things that hopefully you guys will be playing with in a few hours.
Right, and if you want to know more about it, there's also a session tomorrow called Our Maps, Your Business. And so if you want to get a more in-depth look into Google Maps Engine than we're going to do today, I highly suggest attending that session.
Yeah. OK, so as we mentioned, there's a lot of kind of common patterns. You look at all different kinds of applications, and we just showed a small subset of the kind you might be building on the previous animation. And we see very similar patterns. So we're going to go ahead and start out with some crowdsourcing example to show you what we mean.
Right. So also during Hurricane Sandy, we had another very popular layer that made its way onto the crisis map. Because of the extensive damage to trees and power lines that were down, a lot of the residents had no power for days and weeks on end. So a lot of folks actually did have generators, and there was all of a sudden like a 1970s gas shortage inside of New Jersey and New York. So some enterprising young students decided, hey, why don't we get people feet on the ground to try to make a map of this? So let's define a problem here. All right, we need to map which gas stations have gas. That's a fairly simple problem statement. How do you go about approaching that? So you might think, well, let's go ahead and create a form, right? We'll get a form out there. What's the name of the gas station? What's the address? Is there gas available? And you're probably going to host that form somewhere on the internet. And then the idea is that you're going to make this as viral as possible, hopefully get some press behind it, and people are going to come in and submit that type of information. But you can't really trust everybody. Most times people try to do good during crisis, but there's always somebody that's going to come in there and troll. So you're going to have some sort of moderation capability in there as well. Somebody that can be able to approve things, somebody that you trust that's been working on the project for a while, that you trust their opinion. And then you have to be able to make this spatial. So you're going to want to export that into some sort of format, whether it's KML or GeoJSON or whatever the geo flavor du jour is. And then, like we saw with Skylar, you really want to make sure that if you have a database or if you have some service that's generating these feeds, that you're caching out the results, right? You don't want people hitting your live service. And then, and only then, when you're up and running, that's when you want to put this data on a map.
Right, so make a brief segue here into something we see happen a lot when people start collecting information that's spatially related, is you come up with this type of form that I mentioned earlier. You got all the information you think you need, the address, even the latitude, longitude. And I've seen forms out there just like this in the wild, and I just want to say that this is not a very good form. So part of best practices for your architecture is taking advantage of other people's architecture. So this took me like 2 or 3 minutes to modify this form that I created in Google Spreadsheets under the form, and added an interactive map and a little drop-down. So if I'm looking for a gas station, say Exxon, and it'll pop it right up. And this is just cut and paste code directly from our example, super easy. And if I happen to know the gas station's there, I can kind of drag it over and update the latitude, longitude. Those fields should be hidden. Users should never know about that. Anyway, you go ahead, you say there's gas there, you submit the form. And what you should see, there it is the crowdsourced information coming into your spreadsheet. Then we've added an extra column for confirmed, where a smaller select group of people can modify that. Now, once you're at this stage, you have a whole bunch of data. We want to get it out into the map. This is pretty easy. The form took just a few minutes to create. I could go here to Tools and use AppScript. Now, if you're interested in creating really amazing forms with really powerful AppScript integration, you just missed a talk on that. But you can catch it on video. I think they're all going live in the next day or two. So the talk for that is called, I believe, Forms. Use AppScript to create dynamic forms. So pretty cool talk where they go over the power of AppScript and all the kinds of things like you could do. For example, if something new comes in, you could send that data to a different API or service that you have to run some computation in it, and all kinds of dynamic interaction you can do with AppScript. But the easiest way to go from here is just hit File, Publish to Web, and then you get the power of the Spreadsheets API. The data comes out, and kind of RESTful requests that you can make it public. People can hit that feed. It scales reasonably well. There's a little extra work, though, involved in sort of transforming that data feed in XML or JSON to something more sort of map-friendly, because this would not necessarily have that in mind. So keep in mind those trade-offs if you're just going this really simple way. And also keep in mind the trade-off of this is not designed for, for tens of thousands of points. Of course, spreadsheets can handle that. It's too much data to send over the wire to the client on all these dynamic requests. So a super simple way to get up and running, just think about the way you're bringing the data in and how you want to publish it out. Oh yeah, and then a lot of people, when we mention scalability, they think immediately QPS. What is the queries per second? I don't know how many of you have noticed the little sensors we have around Google I/O. Hopefully you guys have seen that. We have hundreds. There's one right on stage tracking me as I talk. And tracking you if you walk by it, and tracking 5 or 6 other different things, including temperature and all kinds of readings. There's a great talk on that, the data sensing lab, tomorrow evening. Check out the architecture there. My point is here, we have a whole bunch of data. This is also crowdsourcing. The issue here isn't tons of people hitting the site, but rather tons of data. Every few seconds, they're sending a variety of different signals back to a server with upwards of thousands of these sensors. You're talking tens, hundreds of millions of data points over the course of days or weeks. So that's a lot of data, and it's more than most people have. It kind of gets in the realm of big data. And so think about that if you're going to have a big data set that maybe the standard tools that you're using for crowdsourcing or even maps aren't going to apply. Now, luckily, it turns out almost nobody has big data. Everyone wishes they did, and big data conferences are fun. But when it comes to mapping and GIS, most people have medium-sized data.
So what do we mean by medium-sized data? This is a class of data, like Josh said, that most people actually have. This is the data that's too big to send to the browser, but not quite big data. We're talking greater than 5 megs, probably up to a couple million rows at max. So what are the strategies and what are the patterns that you want to employ when you're dealing with this type of data? This is important since it is what most of you have. So if you have a small area in San Francisco, you can probably get away with pushing all the geometries to the Google Maps API and actually drawing them as an overlay here. But what if you wanted to take that layer and push it out to all of San Francisco? We're now talking about a couple 100 megabyte file that you have to be able to try to push into the client, and that's not going to be a happy day for anybody, right? Because you want to keep that density, you want to make that map interactive and have all the data there. So what's the easiest strategy? Well, it's nothing really novel. What you really want to employ is take that data, and then you want to break it up into a server-side rendering of that data. You want to be able to just make a simple overlay of 256 by 256 pixels, but it's not just a rasterization process because people are going to expect that these parcels are interactive. So you have to have a strategy for being able to do some sort of interaction, whether that means you're using some sort of a UTF grid or you're using some other technology that you're making that click actually respond and get data back. So if we take a look at the diagram from the architecture standpoint, it's not too different from the crowdsource. You've got one or maybe a couple people collaborating on uploading a big data set. You probably still have some moderation piece. If you're a county and you're doing a tax assessment and you're going out and you're changing polygons, you need to have some sort of moderation piece. But then you need to have this server-side rendering piece that's going to take that data, that vector data, rasterize it, and also keep track of the attribute data for you. Again, you're going to want to have a cache. The nice thing about having static tiles is there's kind of a cache built into that in the sense that the tiles are the cache, but you also want to make sure that it's load balanced, of course. If this becomes a very popular site or your map goes viral, you're going to make sure that you can handle the traffic load for it. And then you publish it out to the map.
Yeah, so I saw this really innovative site, and it's almost sad that it's innovative. It's a JS portal for City of Palo Alto. I think they launched it about a month or two ago. And it kind of stood out to me because I go to a lot of GIS data portals, and it's usually, after going through some click agreement, just a list of downloads, hopefully in a format that your standard GIS software can read, often not, and sort of no idea what the data is until you download it and put it into some sort of GIS system. And what I liked about this site in particular is you can kind of scroll down, play with the map, click on things actually directly, see that you can have some fairly complex data. Here's some land use data, for example. It looks pretty good. You have an immediate idea of what it is before you jump in and then potentially choose to download or otherwise play with the data. Pretty cool. So let's go ahead and see how you might go about building that type of application and just a simple way to do it. So just as we walked you through it in the crowdsource example using sort of Google spreadsheets, talk about our Maps Engine platform here. So again, this you guys can get some test accounts by going to the sandbox if you haven't signed up already. Let's go ahead and dive in. So the first thing you're going to do is you're going to have some data, hopefully. It could be a KML, it could be a shapefile, a variety of other formats are supported. You can upload those files individually, or what I like to do is click the upload button and choose a folder. And that folder could just be full of all different kinds of GIS data, and then it kind of just batch uploads it all with one click. OK, so you've uploaded your, what we call data sources. Now you want to make a map. And we do that by creating what we call a layer. And that is basically some styles associated with your data. So we have some pretty nice styling widgets here on the left. You can go ahead and set filters based on zoom level or attributes. So if I want to style all the parcels that are on a certain type of street, it gives you a nice little drop-down, auto-populated based on your data. Won't go into that too much. The next kind of point here is you can also upload custom icons. So for example, I brought in some trees earlier as an example. We have a whole bunch of nice icons, but if you don't like them, you can upload your own icons that look according to your brand or whatever icons you like, and style with those. And then the other key piece here that it adds is really robust and simple ways to share the data out. So it uses the exact same sharing dialog you might be familiar with from Google Docs and spreadsheets and so forth, where you just select the people that have access to the data, access to the published or unpublished versions. And I won't get into that too much now either, but it's a kind of a key principle. It's kind of that moderation flow. You can have a published version that everyone sees, and then some along the stages of creating layers and maps, versions that only people that you trust or within your organization can play with. So the kind of most exciting thing that I want to talk about is our relatively new API, which we made public just last week. So I'm not sure if many of you have a chance to check out the documentation. I'll point out a couple things. Those of you who are familiar with GeoJSON might recognize it. That's the format that we spit out by default if you make a query for features in your data set. So that's kind of nice. It's an interoperable standard with lots of other software. And then what can you do with that? So let's take a look at some of the other endpoints of the API. To walk you through some of the things that the API offers, I put together this pretty straightforward application. If you see the URL, I'm sure you can't. The URL is googlemaps.github.io. So if you go to GitHub and look at our Google Maps account, you'll see a project under there called Galley. This is the Galley application. It basically is a sort of proof of concept for working with the Maps Engine API. So I'm going to go ahead and authorize it. What's nice about this, it's using the GitHub pages, is there's no server in the background. I use the JavaScript OAuth library to authenticate in. So that's kind of nice. You can build just a straight web app, use OAuth, authenticate in securely, and you have access to all the stuff that the user should have access to. In this case, I have access to 2 projects. I signed up for one of those test accounts, so I have access to that, and I have access to my Josh Livni account. We have access to all of the data and endpoints. Some of the things I mentioned before, the maps, the layers. I can render the layers if I click, for example, on the trees and zoom in. Should be able to see all of the trees that we rendered according to the styles that we had. We also have access to the tables. This is kind of your data sources. I'm just going to give an example of how we can interact with those. So I downloaded the parks from City of West Sacramento. And I'm going to go ahead and zoom into some parks here. Click on this park. And I can just go ahead and edit things. And the way this is doing this, I'll just get rid of that exclamation mark I added earlier, send it back to the server. And it makes a post, kind of a RESTful interface. And now that data is live. So the next people who view the published maps are going to be able to see my updates. Oh yeah, let's see some satellite data. And I can also go ahead and edit the geometries. So a very simple tool, just using the Maps API geometry editing. I can go ahead and drag this around, add a little park space. That's probably not legal. Hit save. And there we go. Again, posted back. So this is a simple way to play with the application. Feel free to check out the code on GitHub. I tried to document it nicely so you get an idea of how we're interacting with the API, how you can build similar applications. You could imagine, for example, that crowdsourcing app, it starts to need a little bit more robustness to it. You could go ahead, use AppScript to push the data to Maps Engine on certain things occurring in the database, like things got confirmed. And now you can render those out, again, like Brian mentioned earlier, using the same power that we have behind Google Maps itself. So all of this data is sent out to all of our data centers, super duper fast, rendering using the same technology we use to render the base map. So that's a great way to publish your maps.
How many lines of code is that?
The grand total, it's about 600 lines of code, I think, including the documentation. So it's a super simple app. I think Twitter Bootstrap helped me out a little bit, as did, obviously, the OAuth JavaScript library. I didn't have to pay attention to UI or authentication. But it's really, really simple to build an application like this. So if you need a map editing tool, feel free to fork it and have fun. Oh, yes, thank you, Sean. So we also have assets. Assets are what we kind of call all the stuff you put into Maps Engine. So it includes, if you scroll down the left-hand panel, all of our tables and maps and so forth, but also a whole bunch of other stuff over on the East Coast. Maybe, Sean, you could tell us a little bit more about what those things are.
Yeah, so the nice thing about Maps Engine is it's not just about vector data that we've been talking about. And that's where we're going to pick up our story with the next type of data that you might be coming across, which would be imagery. So Imagery, we're probably familiar with it. Here's a shot of us here at the Moscone Center, nice 15-centimeter resolution imagery. But it's not just photographs. It can also be charts. You might have charting data, like this NOAA RNC of Oahu. And same strategy applies that we talked about with the medium-sized data. This is kind of where Google Maps got its start, like Brian mentioned, is actually doing the tiling and creating a static tile cache. So the same principle applies. You need to have some server in place that's going to take that image, chop it up into 256 by 256 pixel images, and then serve them out. Now, it's really simple once you have those tiles to overlay them with the Google Maps API. So if I have a Maps API site, I can just make sure that the tiles are exported into the Web Mercator, which is the standard for all Slippy maps. It's got a EPSG code of 3785. And then if I want to play with the 3D, I want to make sure that I also want to put out tiles in the Plat Carré or 4326. In this case, this is really nice because I've got the bathymetry from Google Earth, and I'm overlaying this nautical chart with all these soundings, and the soundings are lining up underground, underwater rather. So this is an option if you're going to serve a 3D application. You want to make sure that you have tiles in that format as well. So just to review, you've got your image, you've got some sort of server running a tile rendering. Once again, your cache is kind of already built for you because it is static tiles. But you do have to think about if you're going to put it out to two different projections. There are a couple of categories, I would say, and different patterns that evolve when you're taking a look at what the use case of the imagery is. And the first one that I want to talk about is what I would call fast response imagery. This could be, if you followed Public Laboratory and funded this Kickstarter, a great project where you take a cell phone or a camera, a point-and-shoot camera, and tie it from a weather balloon, or you could go and follow DIY drones and build your own drone and put an Android phone in there and a little Arduino to pilot it. Or it could be actually formal imagery, such as NOAA. NOAA goes out and collects imagery after hurricanes, and they actually fly with like really nice commercial cameras in real planes. But the key here is that if it's fast response imagery, it needs to be fast, right? Time is of the essence. Here's an example from Hurricane Sandy. This is Manahawkin, New Jersey, and this is the first eyes-on that we had of the area. And it's pretty dramatic if you take a look at what Manahawkin looked like before. See the bridge coming into this beautiful homes, beautiful little beach town. And then after Sandy rolled through, the dramatic change there. We have all of a sudden a new natural-made inlet, and houses have been wiped out. So Josh is going to tell us a little bit about one strategy that we could use to get that imagery out as fast as possible.
Yeah, again, so we'll take the sort of super simple case first. You have a little bit of imagery, you want to get it out to people as quickly as possible. There's tons of proprietary and open source tools and workflows available for this. I'm going to show you one example using the GDAL library and Google Compute Engine. Now, I'm not sure if you noticed any of the talks from the cloud track this morning, but Google Compute Engine, I believe, is available to everyone tonight. And also, they've announced a bunch of other great stuff like sub-hour billing, and you can boot up lots of instances and turn them down as you need and so forth. So the way to get access to this is you go to the developer console, which is the same place you might, for example, get an API key for Google Maps. You go to your services tab and just enable Google Compute Engine. So once you've done that, you'll see a Google Compute Engine logo. You can go ahead and click on that, go to the Instances tab, and then there's a variety of options. I like to just choose a standard Ubuntu instance. Don't worry too much about the other parameters. Boot it up. We're going to show you how easy this is. So you boot up a server. You SSH into this server, this virtual server that runs in our data centers. And then you just run two command lines to kind of get up and going with GIS on a server. Install Apache 2 so that I can have web requests coming in. We're going to serve out some tiles. And then go ahead and install Ubuntu GIS, which installs a whole bunch of software, including this GDAL library. After we've run those, we're going to go ahead and download some data, some imagery data, and then we're going to use the GDAL to tiles library, which is a little Python script, basically, that will mosaic that data together and create all of the appropriate tiles in all the appropriate projections for you. So it took about 2 minutes, I think, for the data we downloaded. And rather than waiting 2 minutes, we made a video. I think it just finished.
Yep,
so that was it. Download the data, created some tiles, done. Now we have the tiles in a folder. And let's take a look at the results.
Great. So the results of that, we have a nice little embedded Google Maps v3 API site here. And I can zoom in to that area that looked really damaged. And I have a nice little custom overlay here, so I can do a little transparency slider. And you can just really start to see the total destruction. Now, getting this out to people, especially the people whose homes those were, the first responders and rescue folks coming into the area, is critical. So this is a perfectly fine way to address a small area get that data out there as quick as possible with minimum friction, as long as you understand a little bit about the GIS tools behind the scenes. But what if it's not a small area? What if it's like a really big area? In America, the United States is a pretty big area. It's about 8 million square kilometers. And so what if you wanted to do imagery on that scale? And what if it was fairly high resolution? I'm not talking high resolution like we showed earlier, 15 centimeters, but the USDA NAEP program, every 3 years basically recovers the United States in 1 meter imagery. So you can take a look at the Moscone Center here. Obviously, it's not gonna be totally exciting in urban areas, but it's not really designed for urban areas. It's really designed to go out and survey agriculture. They fly it in 4 bands, so they can also do some photogrammetry telling different crops that are being grown. So this imagery, if you had it for the entire United States, which we do, for the past 3 years, would be about 80 terabytes of imagery. So my first problem is now I need to upload 80 terabytes of imagery somewhere. And then it's not just that imagery. Now I actually need to make tiles with it. So take that same 3 years of data, I'm gonna tile it out. It comes about 1.3 billion tiles that I need to write to disk. And that in itself is about another 30 terabytes. So now I've got to worry about how many disks I need, how much CPU and RAM I need to spin up, how long this is gonna take. And there are a lot of really smart people working on how to do this with big MapReduce processes. My recommendation would be not to try to reinvent the wheel. So we took all of this, we put it into Google Maps Engine, and we blended and served redundantly over thousands of cores in a few hours. And when I say we served it redundantly, we're writing this to multiple data centers at once for you with Google Maps Engine. So we're actually taking all of that data. We only tile it out to multiple, not just one data center, but across multiple data centers, and it's ready in a few hours. So take a look at a quick preview of this. Here we have a 2D map, and this is the default map that you would get with Google Maps Engine. This is built for you. This is the Google Maps view. And you can come in and see it's just as performant as the underlying tiles that are there, the 1 meter. You can go back and forth, on and off. And the nice thing about Google Maps Engine, if you remember I brought up before that I wanted to serve both 2D and 3D. Well, Google Maps Engine doesn't charge you the overhead for also doing that in 3D as well. So you get a lot of bang for your buck running on the same servers that are running the rest of Google properties. And there's another thing that we should talk about as well. There's a security piece here. I can share that map, and I can make it private. Maybe it's licensed data. Maybe I can't put it out to the entire public. So I have the security things that we talked about with Josh. But we've only talked so far about putting this data out onto Google properties, Google Maps and Google Earth. And if you work with anybody in the GIS community, they love it, it's nice, but they also want to be able to use it in their analytic applications. So if you were going to do this yourself, you now have to think about how am I going to implement things like OGC standards? How am I going to put out a WMS feed? Am I going to have the overhead of returning WMS requests? Google Maps Engine does take care of that for you. And so you can put it out into OGC compliant feeds that can work with other applications outside of the Google framework.
Thanks, Sean. Yeah, so hopefully you can see that even from a little bit of data, maybe it's vector data that you're crowdsourcing, maybe it's a little bit of imagery, many of the same things apply. If you just have to serve it up to a few people, it's static, you're not worried about a huge influx of data or dynamic requests taking you down, then there's a ton of tools and options out there. As people start adding complexity, and this is inevitable for most popular applications, and they need to think about things like the moderation piece, the simple sharing piece, the permissions, and so forth, the different projections, the OGC standards, make sure that you're using a framework and thinking about that in advance, so when you do get popular one day and someone starts slamming you, you have a cache ready. Or when someone says, we need to take care of some moderation issues, you have a method in place to do that. So hopefully we showed you through some different stories that many of the same patterns arise. We've tried really hard to put out some software that makes this as easy as possible for you guys. Hopefully you got and try some of that software, including Google Maps Engine. Let us know what you think. And also, let us know if you have any questions. I think we have about 10 minutes.
Yep, thank you.
Yeah, thank you very much. If you do have questions, please come up to the mics and speak into the mics, and we'll do our best.
Agriculture firm based in Des Moines, Iowa. And I know that was interesting.
Not a plant, not a plant. Okay.
We have a problem, and that is that a lot of people in the agricultural industry live in, work in areas where they don't have good access to the internet. And so I'm curious if you have any suggestions for patterns and practices that would help people when they're wanting to look at map data and they do not have an internet connection.
Yes, in fact, we have a session tomorrow. Sean Madej and Avinash Bhatnagar are doing basically what happens when you have to go off the grid. I highly recommend taking a look at that. There's commercial applications, but there's also grants that we do that basically allow cutting from the Google Maps engine platform. So you can actually take portables of the maps that you create and take them with you in a portable cache that you could run on a PC, Mac, or Linux server.
Cool.
Yep.
I had one quick question, using this Google Maps data and other, can you take the different scenarios for the Bermuda Triangle, because people who go there, they don't come back, I heard, right? So Bermuda Triangle, right?
I'm sorry?
But there's something called Bermuda Triangle where,
Oh, the Bermuda, yep, sure.
yeah, so where if a ship goes, it doesn't come back, or if people go, they won't come back. So maybe using this maps data, you can find out what is the geographical forces which is making it so dangerous, and get some conclusion of that.
That's an interesting idea. I'm actually surprised somebody hasn't made some cool mashups of,
Yeah.
I'm sure the satellites have lots of imagery.
But
you might-
actually, there's a talk tomorrow. Oh, man. The AIS talk.
Setting us up, true, yes.
About tracking all the ships in the world
Yes.
and using BigQuery and Google Maps on doing that. So I think
Good
that's a
call.
perfect place to
Yeah.
ask that
In
question.
fact, we have a
Bermuda Triangle,
few.
we have to find out what is happening there, There's so much of energy, wind energy. So we can also use that wind energy for this Google card, then you can put a card there and see what is happening.
It's a good question. Yeah, I'm certainly no expert on ship data, but we happen to have some experts on ship data giving talks at different tracks. So check out the descriptions. I think we have like 2 or 3 talks.
there's 2 or 3
And these
talks.
guys really know about ships and where they go. And we're going to be showing that. So that's probably a better
Also
question
the
for
reason
some of them.
why there is so much of energy there, wind energy there, So all that energy, we could use it for something else, right? So maybe using those analytics and the data from the Google Maps, we could do something.
Very possibly. Thank you.
Thank you.
Hi, you kind of wowed me with the forms example and the map to the side. You said it was pretty easy to produce, but my experience with forms is it's quite limiting. And I was just curious if you could go into a little bit of the details on that. I mean, did you create a sidebar with the map, and that's how you got it to record lat longs in the form?
Sure, so the way that I made that form was what I'd call the old school way that I don't recommend. But what I did is I created the form using the forms widget. You had forms and spreadsheets. And now, of course, you could create easily your own form. You have an open source CMS, Django-based or something, create a web form. It's just a web form, you're trying to get it somewhere. But in any case, what I did is I modified the Google Spreadsheets form to have all the fields I needed. Then I downloaded it, and then I opened up the HTML, and I added a tiny bit of JavaScript to attach to the fields. Took me about 5 minutes. Went to our examples for autocomplete, and I just cut and pasted some code, changed the input field, and it was done. So it was pretty easy. But as I mentioned, there was a talk that was, I think, just last session, where they go over how to do that correctly. So AppScript is super powerful, and you can do all kinds of dynamic things with the forms now. And so that talk will be on video, and that would be a better way to approach the problem.
But we'll also have this entire talk hosted, so you'll have the slides to go in and take a look at the source as well.
Yep. I'm scared now.
Thanks.
Hi, I'm Andy. I work for a company that provides solutions that overlay map data on top of Google Maps. And one question I had was, in your best practices recommended, you talked about mashing up large imagery in tiles and serving that out. But I also heard in the keynote this morning about the vector maps and how that's kind of the way of the future. So what do you recommend best practices on serving up vector maps?
Right. So I mean, one thing to say is that when you have imagery, unless somebody has a really amazing algorithm, that's not going to get vectorized anytime soon. I think we're still going to be in that world for a long time. But yeah, do you want to take the vector?
Sure, yeah. So today we try to serve out the tiles as in the most appropriate format. So the hope is you upload your data vector, in this case, to Google Maps Engine, and we'll serve it out appropriately. If one day it turns out that the appropriate way to serve that data is in vectors, that's the way it'll be served out. So the idea is you don't have to concern yourself with that. Now, there are some talks. I think Brendan Kenny is giving a talk on some amazing things you can do with WebGL and creating your own vector data that gets displayed on the client, and that's a good talk to go to. I think it's called HTML5, A Love Affair, and Maps, A Love Affair. And there's a bunch of ways you can do it yourself. But yeah, obviously, we have a lot of technology, and we believe that is a really great way to go. And we'll make sure that your data is served up when it makes sense in the right way.
Thank you. No problem.
Good day. I have one question. Please tell me, I want to keep a road graph. Can I keep a road graph by tools, by storage? If I have maybe 10,000 or 100,000 vertices in my graph, And I need in calculation, maybe routing calculation, maybe by Dijkstra algorithm or another. Or I must keep it separate, many vertices on my server for calculation and some vertices for visualization by your maps engine.
So,
what about performance?
Yeah. So right now, like doing Dijkstra or A-star or anything like that over, a vector network is not something that Maps Engine does. But when we talked about Compute Engine, you should think about that as a possibility to be able to run the traditional, PostGIS or PG routing types of applications in a database in an appropriate form until we can offer that as a direct offering in Google Maps Engine.
But if people create some vertices of road graph by themselves, then we have a catastrophe or another sites. Can we use storage as a local cache, as front-end server for our backends in order to send it backends?
Yeah. So
visualize.
The general pattern there is if you would like us to render it out, we have the API. So I showed a really simple example of editing some geometries, but of course you can batch post a whole bunch of features into an existing table, modify or delete them. So if you need to do some type of synchronization or adding new things to data that's in Google Maps Engine, you can do that using the API.
Sorry, do we need in Nginx server for balancing between my backends and your storage?
Not sure I understood that exactly.
You're asking how to connect between your backend, what database, what it would be, and ours?
I don't know about average number of requests to your storage. What about it?
Oh, you mean if you're doing like a whole bunch of requests very frequently, what are our limits? So we have a few different limits. I think right now, if you purchase Google Maps Engine, I'm not sure exactly offhand what the queries sort of per second is that you can post and get. It's pretty high, and I think you can sort of, as with many of our offerings, purchase more quota as you need. I'm not sure what it is offhand by default, but it should be plenty. I mean, it's many a second, so, and you can batch post a large number of features at once. So I think it should suffice.
And if there's a use case you really want to dig down into, please come by the sandbox.
Yeah, we can talk a little more detail, something specific.
Quick question. In your imagery example, how was that 30 terabytes of data delivered?
How is it delivered?
Yeah.
As tiles.
I'm sorry, delivered to the Google App Engine.
Oh, how do we upload the initial?
How did that, yeah.
Okay, so there's technology that Google has called Xenon, which like Josh said, there's one way where you could sit there and try to bulk upload all of that. For the 80 terabyte source, you probably don't want to do that. Xenon is a technology that Google uses to monitor remote web servers, where we have a lot of partners such as was it Vivo that puts out a lot of music videos, and we monitor either a HTTP or FTP site where we will actually pull that data across data center to data center, and we can ingest that for you into a particular account. So it needs to be on a server somewhere, or if it's a really big delivery like that, we can actually have customer agreements through some of our partners that'll help get that data online for you. Because yes, getting a large amount of data into the cloud is a barrier to entry.
Okay, well, thank you guys very much for coming. Sean and I will be in the Google Maps sandbox for the next hour or so. Look forward to chatting with you guys.